Hello, I hope you are doing fine today. We have come again to continue from where we stopped. I will not let you down and I will not let you rest. So, I don't also want you to allow me to rest because the more you watch it, comment, the more I believe that you are expecting more. So when you watch these videos, keep commenting, and then I will be pushed to drop more. Okay, so today we are here and we are still going to work on Jamb class, past questions on Jamb. So now the question we have, they have given you a conical flask suspended inside of it a test tube that carries solution X. Now, if you check the test tube inside it has two ropes, maybe threads, holding it, one close to the mouth, one close to the bottom, somehow like this, so that the content will not pour. So this is the content, solution X. Now the same thing, okay, so but inside the flask, you have solution Y already there. So now this is for experimental question, and experimental test of the law of conservation of mass. The law of conservation of mass is illustrated in the diagram above. In practice, the flask is weighed before and after the reaction between solutions X and Y. See solution X here, see solution Y here. Which of the following pairs of solutions will be unsuitable for the experiment? They have given you A, X to be hydrochloric acid, Y to be silver nitrate, B, X is your barium chloride, Y is dilute sulfuric acid, C, X is hydrochloric acid, while Y is sodium hydroxide, D, X is hydrochloric acid, while your Y is lead nitrate. E, your X is hydrochloric acid and your Y is sodium carbonate. Which of these is not suitable for you to use and carry out this experiment? Now, note what is this conservation of mass, the law of conservation of mass. State that matter can neither be created nor destroyed, but it can be converted from one form to another. So, you cannot create a new thing, you cannot destroy anything completely. So this thing, they said before and after, they after setting it this way, you carry it like this, put on your weighing balance, take the mass, assuming you have 20 gram. Now bring it down and draw, that is before the reaction. Now draw up this thread that is holding the bottom of the test tube, and then draw the thread up. The bottom will go up and you see the test tube. The mouth will still be there, the bottom alone will go up, and then the test tube will turn and be like that. So what happens to the content? Everything will pour out. So when it pours out, it goes into this solution Y. Now you have X and Y mixed together. Check small. Allow the reaction to take place. After that, precipitation will occur. Now the reaction has taken place. Carry it like that, weigh it again, and confirm the mass. That's verification of this law. Confirm the mass, whether it will still give you exactly what it gave you before the reaction. So this mass should, according to this law, what you had before should give you what you are obtaining now, the new mass. It should be the same. Despite that, the reaction has taken place and new products are formed. It should give you mass. There should be no increase in mass or reduction in mass. That's what the law says. Okay, now which of these is not suitable for this reaction? How do you answer this question? Now, note, very important. For you to be able to answer this question, you should be able to know if I react this with this, what will I have? Now, if I draw a line, and let me start by with A. A said hydrochloric acid. Some of you quite unfortunate that you may be preparing to write Jamb, WAEC, you don't know how to write chemical formula of a substance. Go back to one of these videos that I taught and watch it, know it, so that it will help you answer this type of a question. Now, A, if I say A, the substance is hydrochloric acid. The formula is HCl plus, that's X, reacting with Y. My Y is what? Silver nitrate. AgNO3. When you react, you will have double decomposition and then the radicals will be swapped. Then Ag here will take Cl. This is aqueous since they are solution. They are solution. Now, by the reaction, after the reaction, you have AgCl. This is solid, which is PPT. Solid substance is formed. Now, HNO3, aqueous, is also formed. Now, let's go for B. B. Let's see B. What will happen? Barium chloride. Barium chloride, BaCl2. Solution, since they told us solution here. Solution plus B, barium chloride solution, plus dilute sulfuric acid, H2SO4 solution. When you react these two, what do you expect to have? You will have BaSO4. The cation here, the positive will take negative. Positive will take negative. So you have what? This is solid. This is solid. And you have HCl. Aqueous. So that equation is not balanced, but the balancing is not the main thing now. But in writing equation, you need to balance it. So now you have that. Let's go to the third one. C. C says what? Hydrochloric acid and sodium hydroxide. HCl aqueous plus NaOH aqueous to give you NaCl. This is aqueous plus H2O liquid. Okay, so now let's see the next one, D. D, where's D? Hydrochloric acid, lead nitrate, HCl plus Pb into NO3 2. Solution that will give you Pb will take Cl2. PbCl2 solid plus HNO3. HNO3 aqueous. Aqueous. Okay, I'm not sure that equation is balanced. One here, one there. NO3, NO3. If I put two here, I think that's okay. Okay, now E. E. Hydrochloric acid HCl aqueous plus what? Sodium hydroxide, sodium carbonate plus Na2CO3. This is aqueous. When reacting them together, you now have NaCl aqueous. You have H2O liquid and CO2 gas. CO2 gas is formed. Okay, now looking at that equation, looking at this equation now, to balance that equation, looking at that equation, those equations now, check them very well. You now see that in verification of this law, this man can be used. Why? Let me tell you the reason or what you should be looking for in equation like this. Look for a substance, a reaction that will produce a gas. A reaction that will produce a gas is not qualified to be used in that situation. So you cannot use that to verify the law of conservation of mass. Now, which one gives a gas? The last equation. So E, when you react the two substances they gave you, you have sodium chloride, you have water, and you have CO2. This reaction is designed in a way that you don't supposed to miss anything. But in driving this, when that gas is formed, the gas can pass out from here with its own mass, whereby there will be a reduction in the mass. The mass will not be exactly what it was. Something has gone out from it. So, in verification of this law of conservation of mass, the reaction should not produce what? A gas. But in this case, this one is the one producing a gas, CO2. The rest of them, none of them is producing CO2 or any other gas. So they can be used. A, B, C, D can be used. Apart from what? E. So I believe you enjoyed this lecture. So let me give you something to do. Okay, now let's see the assignment. The size in bracket diameters of 5 atoms are in the order R less than T less than W less than X less than Y. Full stop. Y being the largest, that means R is the smallest. Like that, it increases. If each has an electron situated on its circumference, neglecting other factors, which of the atoms will lose its electron most reluctantly? Which of them will lose their electrons most reluctantly? A is or A says R, B T, C W, D X, E Y. Which of them will lose its electron most reluctantly? Tell me the answer, and possibly tell me the reason why you think that option that you are going for is the correct answer. I believe you enjoyed the class. Keep following the channel. Comment, like the channel, share with your friends, subscribe, and then let's see how it will help you. See you some other time. Thank you.